Hello everyone, I'm Frank, and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle, and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called X's and Arrows by Abby, and here are the rules. We have standard 9x9 Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have digits on an arrow summed to the digit in the attached circle. So, for example, we could have something like, say, 3 and 4 here, and this would add up to 7, because these two digits must add up to the digit in the attached circle, and 3 and 4 adds up to 7. So that's an example of how arrows works. We also have XV clues, where digits separated by an X sum to 10, and those separated by a V sum to 5. And not all X's and V's are necessarily given. So say this was a 3 here, this would have to be a 7 here to add up to 10. Say we had a 3 here, then this would have to be a 2 to add up to 5, because there's a V between them. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, well, we have an arrow here, which adds up to 5, and those are the only two digits on the arrow, so therefore this must be a 5 here. And this must be 1, 4, and 2, 3, adding up to 5. We also have these digits are 1, 4, or 2, 3, adding up to 5. In addition, the digit in the circle plus these three is equal to the sum of these three digits, which are unique digits because they are in the same column, plus this digit here. This is at minimum 1, 2, and 3, which adds up to 6. So 6 plus 1 would add up to 7 at minimum. And you can only be 9 here as the largest digit, so this is 7, 8, or 9. And this is the same thing. This is 7, 8, or 9 here. So this must be 1 through 4 here because they add up to 5. And this digit, again, these add up to 6 at minimum. So 6 plus 3 at maximum would add up to 9 here. So this is a maximum of 1, 2, or 3 here. Anyway, anytime you have two digits adding up to another digit, and they're both unique, you have to have at least one of those digits must be from 1 through 4. Because to add up to the largest digit, 9, you could have 1, 8, 2, 2, 7, 3, 6, or 4, 5. Again, 4 is the smallest digit there. It's the largest, smallest digit there. So you're guaranteed to have a digit from 1 through 4 here. And you have a 1 through 4 here, and two digits from 1 through 4 here, and another digit from 1 through 4 here. So this must have 1 through 4 here, which means that the rest of the box cannot have 1 through 4. So one of these digits is 1 through 4 here. These are both low, in other words. One of these is low, which means one of these is low. So let's mark these as different lows. This is a pair. We'll mark that as the green lows to add up to a certain amount of 5. Well, where are they in column 5? These two digits must be from the other pair. That's adding up to 5. Because if this is 1, 4, this has to be a 2, 3 pair, right? Because these digits, again, one of these digits has to be at maximum of 4. So it's guaranteed to have one digit from 1 through 4 here. This is 1 through 4 here. So this pair of digits adding up to 5 means this has to add up to 5 here for this pair of digits. Because if you have 1, 4 here, you have 2, 3 here, which again adds up to 5. If you have 2, 3 here, this is 1, 4 here, adding up to 5. So we have a digit here. It cannot be 1. If this is 1, that would force us to be a 2-3 pair. And then this would have to be, it can't be 1, 2, or 3 here, which is not possible because of the way that this arrow works. So what this has to be then is, this can either be 2 or 3 or 4 here. And we have it with a 5 here, so this must be 7, 8, or 9. Because we can't have 2 digits here from 1 through 4. Because if we did, we'd have 5 digits in this box. That would have to be 1 through 4. And that's not possible because there's only 4 digits from 1 through 4. So this could be 2 through 5, 2 through 2 and 5, 2 and 6, 2 and 7, 3 and 4, 5, 3 and 6, and 3 and 5 and 3 and 6, or 4 and 5 here. To add up to 7, 8, or 9. But if this is 3, this is guaranteed to be at minimum 1, 2, and 3, so therefore this would be 9. So if this is 2 here, that would force us to be 1, 4 here. That would be 3. So we can't have 2 and 7 here adding up to 9, because we have a 3 here with 1, 2, and 3 adding up to 9 in the same box. So this actually can't be 7. So it's either 2 and 6 or 2 and 5 here. You could have any of the 3s here, 3 and 5 and 3 and 6. So these blue 1, 4, 2, 3 pair have to be here. That means the remaining digits in the box are either higher or 5. So these are higher 5. Obviously these can't be 5 because of the possibilities. And these digits have to be the green 1 and 4, or 2 and 3, adding up to 5. That means this can't be green. This has to be blue. The blue 1 through 5, because these both eliminate all possibilities for that pair for these cells here. So we have 2 out of these 3 are the green 1 through 4s here, adding up to 5. We don't know which. The rest of this box has to be higher 5. Which means this is at minimum 5 or 6 here. So this could be 6 through 9 there to add up to these 2 digits. It could be 5 through 8, really, technically. Anyways, where is the 9 available in column 5? Can't be along the arrows. Can't be along the arrows here, so 9 is guaranteed to be one of these 3 digits. These cannot be 2 lows. So these cannot be the green lows here. We have one of the green lows here to add up to 10 with this pair. So these 2 digits add up to 10. And we know these 2 digits by themselves add up to, at most, 17, right? 8 and 9. So that means these 2 digits at most add up to 7, because that's 17 minus 10 is 7. So this would have to be 1 through 6 here, and cannot be 5 because of 5 in the row. And this could be 4, 5, 6, 7, 8, 9 as possibilities. And this is 1 through 6 here, to add up to 7 at most here. Okay. Here is interesting. We have 2 sets of digits, which must add up to this digit. And we have 2 digits here, which cannot add up, which add up to 5 guaranteed. So these digits, at minimum, we don't have 5 available. What's the minimum this could be? Well, either we're missing 1, 4 here or 2, 3 in this box. So that means the other 1, 4 or 2, 3 would be there at minimum. So that's 5, 1, 4. Then we don't have 5 available in this box, and we have 6, 7, 8 available. That's not right. 6 and 7 at minimum available. So 1 and 4 add up to 5. 6 and 7 at minimum add up to... It's too small, I feel. Well, it's not divisible by 2. That's the problem. So 1 and 4 is 5, plus 6... Oh, no, that works. It has to be 6 and 7. 1 and 4 is 5, plus 6 and 7 is 18, which is equal to exactly 9 times 2. So therefore, this must then be some combination of the other 1, 4. So the green 1, 4s are here, plus 6 and 7. And that must add up to 9 here. Because that at minimum is that's the minimum of what 4 digits in this box can add up to. And that's the maximum 1 digit can be. So because of that, we know this has to have 6 and 7 adding up with the digits from 1 through 4. So this has to then be, it can't be 1 and 8 add up to 9. 4 and 5 add up to 9 also. So this can't be 1 and 4 here. Therefore, the green set of digits adding up to 5 are 2 and 3. So this is a 2-3 pair, which means this can't be 2-3. It's 1-4 as a pair. That leaves this as an 8. This can't be 8 and 2. This is 1-4 as a pair. Therefore, this is 1 here. This must be 4. And 4 and 5 must add up to 9. So this is 9 here. This cannot be 9 here, and there's no 9 here. So this is not 1. We have 4. This can't be 1 and 4. It's 2 and 3 then. And 2 and 3 plus at most 5, 6, or 7 adds up to 9 at most. But 2 and 5 adds up to 7 at minimum. So this can't be... Well, we could have a 4 here. Therefore, this cannot be 2 or 3 here. Because it's not going to add up to 10 with this digit here. Because this can't be 1. This can't be 2, 3. This can't be 2, 3. The 8 eliminates 2 and 8 as a possibility. The 9 here eliminates 9 in the rest of the column. Actually, 5 eliminates 5 here. So this has to be 2 and 6, or 3 and 6, or 2 and 7, adding up to 8 or 9. Okay. These two, again, must add up to 7 at most. So this has to be 4 at most here. This has to be a 2-3 pair here, because there's no other possibility for it in column 6. Because it cannot be here because of the 2-3 pair in the box. Can't be here because of the 2-3 pair in the box. And this doesn't add up for 2 and 8 or 3 and 7 because these digits are too big for this right central box, because this adds up to 10. So we know there's a 2-3 here. We know there's a 2-3 here. That eliminates 2 and 3 in the rest of row 5. So these can't be 2 or 3. It's a 6-7 pair. They're not the green pair. So this must be the green pair here and here. And this 2-3 pair eliminates 2-3 in the rest of the row 6. So no 2-3 are there. So this is 1 or 4 here. And this cannot be 3 and 7 adding up to 10. And we know this has to be 2-3 as a low because we have the 1-4 pair already in the row. And if we try to have 3 and 7, that would eliminate all possibilities for this pair here. Or the 6-7 pair eliminates the possibility of this being 3-7. So this must be 2 and 8 to add up to 10. Therefore, this can't be 2 here. It's 3, which means this can't be 3 here. It's 2, which means this can't be 2 here. It's 3 and 6 adding up to 9, which forces this to be 7 and 2 to add up to 9 here. Remaining digits in row 5 are 5 and 9. And this can't be 5 because of the 4-5 pair in the column. So this must be a 9, which eliminates 9 in the rest of the box. And that leaves this as a 5. So one of these 8s is going to have to add up with the 1 to add up to 9. Because there's no other possibility for 8 to be in an arrow. So this cannot be 8 because this can't be 1. Therefore, that makes this 2, which makes that 8 and 1 here, which adds up to 9 there. 2 and 3 would add up to 5, but that's not possible because of 5 in the box. 2 and 6 would add up to 8, which is not possible because of 8 in the box, so this must be 2 and 4 adding up to 6 here, which means this is 4 and 6 here, adding up to 10. And these two digits must add up to 10 without 2 and 4, so it's a 1-5 pair here, which eliminates 1 and 5 in the rest of the column. 1. These digits add up to either 6 or 7. To add with the 1 to add up to 7 or 8 here. Well, 6 is 1, 2, and 3, adding up to 6 or 7, but this digit can't be 2 or 3 because of 2 or 3 in the box. So if we try to have 1, 2, 3, that's not going to work. It has to be 1, 2, 4, adding up to 8 here. And this can't be 1 or 4, so that's 2, which makes that 3. That leaves this as a 1-4 pair here to add up to 8 with that cage there. And this can't be 4 because of 4 in the row here. So this must be 1, which makes this 4, which makes that 1, which makes that 4. Okay. 5 can't be here because of 5 in the row. So this is a high digit, and it can't be 6, 8, or 9. So that leaves that as 7. That leaves the remaining digit in row 4 as a 3. These two digits add up to 8 without 1 or 2 available, so that eliminates 1, 7, and 2, 6 as possibilities. So it must be 3, 5, and this can't be 5 because of the 1, 5 pair in the column. So that's 3 and 5 adding up to 8 there. These can't be 5 because of the 5 guaranteed in one of these two cells. Remaining digits of column 7 are 7, 8, and 9. No 9 here because of 9 in the row. This is... So these two digits... What we have here is that these digits... Well, 7 eliminates 7 here, so that's 6. So this can't be pink here because of the 4, 5. This can't be pink here. So this must be 8 left, which makes this a 5 left here. So 6 and 2 add up to 8. 6 and 3 add up to 9. These add up to 5. 5, can this ever be not... Obviously, this can't be 2 or 3 because of 2 or 3 in the column. So can this ever be greater than 1? If it is, that's 4, 2, 3, which is already 9, plus another 2 adds up to 11. So the answer is no. So this must be 1, which makes that 5, which makes that 1. 6 and 2 add up to 8. 6 and 3 add up to 9. So this becomes an 8, 9 pair there. 6 eliminates 6 as a possibility here, so this must be 7, which makes that 6 there. We have an 8, 9 pair in column 4, so therefore this can't be 8 or 9, it's 7. That leaves this as a 4, 5 pair remaining in column 6. 7 eliminates 7 here, so this is 8 or 9. This adds up to 9 also. We don't know about this. We don't have 1 available in either of those cells because of 1s in the row. Cannot be 2, 7, so it could be 3, 6, or 4, 5 here. And 5 can't be here because of 5 in the row, so this can't be 4 then. These two digits add up to either 8 or 9. You can't have 7 here. So if it's 8, this has to be 2 and 6 adding up to 7. If it's 9, you can't have 2 and 7 here because of 7 in the row. Can't be 3 or 5. So no 3, 6, and no 4, 5. So if it's 9, it would have to be 1 and 8. But the problem is the 1, 8 in column 8 eliminate that as a possibility at all for this arrow, which means 1, 8 doesn't work. So no 1, 8, no 2, 7, no 3, 6, and no 4, 5 adding up to 9. So 9 is not possible. Therefore, this must be 8, with these being 2, 6. 8 eliminates 8 here, so it's 7. This can't be 7 or 8 because of 7 or 8 in the column, so that's 9. 9 eliminates 9 here, so that's 8, which makes this 9. 8 is a sum of 6 and 2, so that's 6 and 2 there, which makes this 3. 1, 2, 3, and 3 add up to 9, so that's satisfied there. This can't be 3 because of 3 in the column, which means this can't be 6. These two digits add up to 8. It could be 1 and 7. No 2 6s available because of 6 in the row. Or it could be 3 and 5, with this being 5 and this being 3. But this 3-5 pair would eliminate all possibilities for this cell in this cage, right? If you have 3 and 5 here, there's no other possibilities for this cell. So this can't be 3 or 5. It must be 1 and 7. Okay. And the rest of this is just going to be from normal Sudoku because we don't have enough information for everything else. Okay. Remaining digits in this right central box, we just have 7. Remaining digits in this upper right-hand box, well, let's figure out where the 7 is in row 7. Can't be here because of 7 in the boxes. This is filled. Can't be 7 here because of 7 in the column, so 7 has to be there. That gives us 8 7s, right? Which, so we know where the last 7 has to be. It has to be there. Normal Sudoku, row 3. We have, what, 4, 6, and 9 remaining. This can't be 9 because of 9 in the column, so we have 4 or 6 available. This can't be 4 because of 4 in the column, so 6 and 9 available. And this can't be 6 because of the 2 6 pair in the box, so this is 4 or 9. Remaining, we have a 4 6 pair in column 2. That eliminates 4 6 in the rest of the column, so we are left with 3 5 and 8. And this can't be 3 or 8 because of 3 or 8 in the row, so that makes this a 5. Which means this can't be 5. That's 3 and 6 to add up to 9. 6 eliminates 6 here, so it's 4, which eliminates 4 there, so it's 9, which makes this a 6. That leaves the remaining digit in column 2 as an 8. 5 eliminates 5 here, so it's 4 and 5. No pink there, no blue there. We have 7 digits accounted for in row 2. The only remaining digits are 1 and 9. This can't be 1 because of 1 in the column, so this is 9 and 1. Remaining digits of row 7, we have 2, 4, and 8. This can't be 8 because of 8 in the column, so it's 2 or 4. No 4 because of 4 in the column, 2 and 8. And this could be any of them. We have column 3, which has 6 digits accounted for, so it's 2, 3, and 8. 3 can't be either of these. This can't also be 2 because of 2 in the row, so this must be 8, which makes this 2, which makes that 4, which makes that 8, and that leaves 3 remaining in column 3. That leaves 2 remaining in this upper left-hand box. So remaining digits in row 1 have to be 1 and 4. No 1 here because of 1 in the column, so that's 4, which makes that 1. We have 5 and 9 remaining in column 1. This can't be 9 because of 9 in the row, so that's 5, which makes that 9. 5 eliminates 5 here, so it's 4 and 5. Remaining digits of row 8, we have 4 and 6. No 4 here because of 4 in the column, so that's 6, that's 4. 6 eliminates 6 here, so it's 2 and 6, which means this has to be 2, and this must be 3. And that's how you solve it. Pretty interesting, actually. I don't know if I would classify this as very easy, though. I mean, if you've done a decent amount of Sudokus, it is. But usually I think very easy puzzles are ones that, like, even just, like, beginners can logic out fairly easily. I'm not sure how much this part is logic. How this would be very easy necessarily. Or it doesn't have to be very easy for beginners, but I think they have to be able to logic things out pretty decently. And I feel like if you have the experience, it's pretty easy. But I don't know how easy it is if you don't. is, I guess, the point I'm trying to make. Um, yeah, I don't know. I'm not sure if I would classify this as very easy or easy. It's very easy to me, and I think to the majority of people who've done a decent amount of these variant Sudoku puzzles. But I don't know. I'll figure it out what my ranking is for this. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.